In this problem, we have a population of 3 values, 1, 2, and 12, and we want to take samples of size 2 from that population, and those are going to be randomly selected with replacement. Now it says randomly selected, but we're actually going to select all the possible samples from the population, and those are listed below. So we're going to start by finding the value of the population standard deviation sigma. And to do this, in L1, I'm going to put 1, 2, and 12, all the values from the population. And I run one variable stats. And I find that sigma x, they put a little x in there, but it's just sigma, and that is 4.967. So that part is done. Next, we need to find the standard deviation of each of the 9 samples. So I'm going to go back to L1, and I'm going to enter the values of the first sample, and that's 1 and 1. And run one variable stats again. But in this case, I'm putting in a sample, not the entire population. So I want to know what Sx is. And that turns out to be 0. And what you'll notice is that if the sample values are all the same, then the standard deviation is going to be 0. So I'm going to put a 0 here for 1, 1, 2, 2, and 12, 12. So I don't need to actually calculate those all separately. I know if the 2 values are the same, the standard deviation is 0. So now I'll go to my next sample. And in L1, I'm going to put in 1 and 2. Run one variable stats. And get the standard deviation, the sample standard deviation, which is 0.707. So, I'm going to put that here. And I'm also going to put it here because the order doesn't matter. So I calculated 2 of those. Next, I put in 1 and 12. Let's do one variable stats. And now our sample standard deviation is 7.778. So I'll put that here. And also here. And now I just really have one more sample to do, which is 2 and 12. And when I run one variable stats, my sample standard deviation is 7.071. Okay, so now I have all the sample standard deviations. And the idea is that we want to put these in order. So the smallest value is 0. And I have 3 of those. So standard deviation is 0, probability 3 out of 9. And then I go to the next smallest value. And when you do this in the homework, they give you a little drop down. So they're not going to let you put in 7.778 for the next value. You're going to have to go with the smallest one. So that's, or the next smallest one. So that's going to be the 0.707, and that goes in the second spot here. And there's 2 out of 9, so that's the probability there. And then 7.071 is next. Again, 2 out of 9. And finally, 7.778. And 2 out of 9. So we've created our probability distribution, or our sampling distribution, for the sample standard deviations. And now we want to find the mean of that sampling distribution. So we're going to enter into L1 our standard deviations, into L2 we'll put the probabilities. And I'm going to type this just as a fraction, 3 divided by 7, and the calculator will turn it into a decimal. So now I'm going to run one variable stats. But for my list, I am going to put in L1 as we normally do. And for frequency list, I'm going to put in L2. And if you don't have the stat wizard, then when you type in 1var stats, you're going to put in L1, comma, L2. I'm going to fix that. L1, there we go. So that's what we're going to put in. We're going to calculate that. And I'm looking for the mean. So the trick of these is to be very focused on what value it is that you want in the situation. So in this case, we want the mean of the sample standard deviations. And we get 3.457. And so now we're going to compare this value to sigma that we found in the first step. And notice that those are not the same values, which we expect that because we know that the sample standard deviation is a biased estimator of the population standard deviation. So the last question, do the sample standard deviations target the value of the population standard deviation? We know that that's a no. In general, do sample standard deviations make good estimators of population standard deviations? No, they are biased. So we want to say that the sample standard deviations do not target the population standard deviation. So B is out, and D is out, and C is the one that says that they are biased estimators, so C would be the correct answer for this. And that's how you do that problem.